video, I'm going to be discussing on how to solve the root for a continuous function using bisection method. So what is it called, bisection method? Because bisection method is a process of solving the root of a continuous function where you're going to solve or find the two opposite signs values. So we have the problem now. Find the approximated value of x till 4 iterations of Euler's number raised to negative x is equal to 3 log of x. So now let's simplify this equation and let this be equal to fx. So now we must rewrite the given equation to the problem, which is the Euler's number raised to negative x is equal to 3 log of x, and let this be equal to 0. Let's transpose this one here to this side, so this will become negative, and the f of x will now be 3 log of x minus the Euler's number negative x. So now let's assume or find number that will be the range of our roots. Now let's start with the number 1. So let's substitute 1 into the x to the x's of the function. So now let's input this equation in the calculator. So alpha shift Euler's number 3 log alpha x minus the shift negative alpha x and calcu, and x will be 1. So at x will be 1, the answer for this is negative 0.36788 or 79. So now that we have negative here, let's find for the positive. And the second one is number 2. So let's replace this or substitute the number 2 to the x values of the function. So again, calcu and 2. Enter. So now at 2, the function will be 0.76775. And now in solving for the iterations or in the problem, we have the formula, which is p will equal to a plus b and divided by 2. So the value of a here will be 1. This will become the a, and this will become the b, the 2. So if we're going to add this 2, 1 plus 2 over 2, this will become 3 over 2 and 1.5. And this 1.5, if we're going to substitute it to the function, you're gonna get 0 at fp, you're going to get 0.351. And in solving for the iterations, we have the rule that the p must be less than to 0. But here in our case, we have p is greater than 0. So we must stick to the value of a and b. So now we have the table. You'll have the a, b, the f of a, which is the product of a here in the function. The b, which is the result of we're going to substitute the value of b here in the function. Then c is equal to a plus b divided by 2. So if you're going to add this one and divide it by 2, and now we have f of c. If we're going to substitute this value to the value of x's in the function, and b minus a, if we're going to substitute this b minus a. So now, so let's start. So first, the value of a, which is 1, the value of b, which is 2, and then substitute, which is this one, the value of this, and b, the value, this one, so this one, and add this 2, so we have to get the 1.5, this one, and the fc is, if we're going to substitute this 1.5 to the value, to the function, so again, the 3 log of x, log of x minus Euler's raised to negative x calc, and this will become 1.5. So here is the answer. And if we're going to define the difference between b and a, this will become the 1. So now, take note that this is positive. If the f of c is positive, you're going to change the value of b, which this will become now the value of b, the c. Okay, take note of that, okay? So, the a will remain, will be the same, but the value of b will be this one, so 1.5. A will still be the same, and b will be, this one, the value of c. And if we're going to add this one, the a plus b, then divided by 2, this will be the result, 1.25. And if we're going to replace, substitute this value to the function which is, this will become the f of 1.25. So this will be the result, 0.004225. And if we're going to find the difference between b and a, this will be the result. So again, the f of c, we are now on the second iteration. The f of c is still positive. So let's now change the value of b. And a will still be the same. So f of a will be the same. And the f of b, so this is now the value of b. And c will change also. This will be 1.25 plus 1 divided by 2. This will be the answer. And now, we have the c. We're going to find the f of c. This will be the answer. And now, take note that we have negative. This negative will be redirected to the value of a. So let's now replace the value of a with this. Okay. And this will become the value of a. And the value of b will still be the same. It will not change from the equation. And now this is the value of fa. And this will be now the value of f of b. And if we're going to add this and divide it by 2, this will be the answer. And the f of c, which is if we're going to replace or substitute all the value of x to the value of c, this will be the answer. And if we're going to add this one or find the difference of this one, we're going to get this. So now that we reached to the fourth iteration, we are safe to say that the approximate root, therefore, the approximate root for the function given is 1 0.25. So that's it, and thank you for listening.